In our last video, we looked at making a box and whisker plot on the graphing calculator. In this video, we'll take a look at how to sketch that by hand, and then we'll interpret the data, the box and whisker plot, to answer a couple questions. So these questions are based on some data we collected in the previous video. So if you don't know what I'm talking about, maybe pull up my previous video, see where that data is coming from. So first of all, let's go ahead and make a sketch just by hand of what we saw on the calculator in the last example. So besides just like making a box and whisker plot, I want to try to be a little bit accurate with this. So what I'll do is I'm going to create an x-axis down here. And looking at my data, I saw that my lowest data, my minimum data for my graph, was 33 minutes spent on homework. So just to make this convenient, I'm going to go ahead and start at 30, and then I'm just going to count up by tens. I'm going to be a little, I guess, sketchy when I do this, but I do want to be somewhat accurate, so I do want to include this axis down here. My data went up to 73 minutes, so I'll make sure my number line goes a little bit past that. I'll go up to 80 by tens here. Okay, this will just give me a little bit of framework, a little bit of reference when I make my box and whisker plot. So I'm going to go ahead and put down my 5 points, the minimum, the Q1, etc., and then I'll go ahead and make my box and whisker plot. So my minimum data was 33, so I'll go ahead and put a dot approximately about there, 33. It's just a sketch, so you don't have to be super accurate. 46 minutes was my next point, my Q1 point, so I'll put about right there. 53.5 was my minimum, or sorry, my median. So about 53, probably somewhere about there. 61 was then my Q3. And again, this data is coming from a previous video, so if you have no idea what I'm talking about, try to find that previous video where we made this box and whisker plot on the calculator. And then once I have those 5 points, I'm ready to make my graph. The end of these will be the whiskers, so those two parts will be the whisker part of my box and whisker plot. The middle is then going to be the box part. So I'll go ahead and make a rectangle around there. Oops, a little bit off there, oh well. And then I'll go ahead and drop that line down the middle to represent the median. So there's a really rough sketch of my box and whisker graph that I saw on the calculator. What I like to do, just because I know we just kind of roughly sketched where that point was going to be, I like to go and when I say include all the important information, I would probably include something like labels on these, like, hey, that's 33 minutes, and maybe if you want to label that the minimum, that's fine. Although we should all know how a box and whisker plot works and what it's telling us. So there's my minimum data. But I do like to include the numbers in there. So 46 minutes was my Q1, my first quartile. 53.5 was my next, my median. My Q3 was 61. And then my maximum time was 73. So that's what I would say would make a good sketch based on what we saw on the calculator in the previous video. So now that we have this, let's go ahead and analyze this data and answer a couple of questions for it. So our first question here asks us about what percentage of students took between 33 and 46 minutes to finish their homework. Well, I'm glad they picked those numbers because I can see 33 minutes and 46 minutes are right from values that I got right in the box and whisker plot. So the 33 piece represents my minimum. The 46 minutes represents my Q1, and because that's one sort of section on the graph, this section right here, remember the way a box and whisker plot works is each one of these sections is approximately 25% of your data, approximately. So what I'll say is the approximate number of students that took between 33 and 46 minutes was about 25%. The same would be true for any of those sections in your box, in your box and whisker plot. Any of those sections, if we were given those values, would have those kids, those students, would have taken about, or would represent about 25% of your group. All right, and then we're also asked to describe the shape of our distribution. Remember, our shape could be symmetric or we could be skewed, either positively skewed or negatively skewed. And this is going to depend on basically the length of the two whiskers of your graph. I've changed the screen on you, but if you remember what our graph looked like, or if you want to flip back in the video, you probably see that the two whiskers were approximately equal in length. Because they were approximately equal, I would say that this represents a symmetric distribution. If one whisker was longer than the other, we'd have either a positive or a negatively skewed distribution. But I'd say this one's roughly symmetric. Sorry. And then based on that analysis, we're able then to describe the center and the spread of our data. Our rule is always going to be, if our data is symmetric, we're going to use the mean and the standard deviation. So that's what I'll select this time. When they say justify your choice, why are we selecting the mean and the standard deviation? I'm going to say it's simply because our data was symmetric. If your data was skewed, then go ahead and select the median and the interquartile range to describe your data. So I'm going to go ahead and, well, let's just get those labeled. So the mean and the standard deviation are what I'm choosing to use. And to find these two values, I'm not going to find these by hand. I'm going to go ahead and I'm not going to show you in this video, but I'm going to explain how I did it. I went and since my data is already typed into L1, I went back and did that one vars stats, the one variable statistics. And if you want to see the video on how to do that, I know I have one up a few videos before this one. So once you run that, you should be able to find this information. The mean, remember, is that X bar that you get when you run this on the calculator. And the mean comes out to be approximately 53.5 minutes, which if you notice, that actually was our median. That tends to be true. When your data is symmetric, your mean and your median tend to be approximately equal to each other. This time they were exactly equal to each other. Our standard deviation then, which would represent the spread of our data, comes out to be about 10.46. And I'm choosing to use, remember we call it the little O with a hat symbol on it, which actually is called sigma, lowercase sigma. I'm going to choose to use that because we have the entire population of the data. We have all the students' data for this example. So that will be my little description of the center and the spread of the data. And again, I chose to use this instead of the median and the interquartile range because my data was symmetric. If it wasn't symmetric, I'd go back and I'd instead describe it using the median and the interquartile range.